The very funny thing is, opportunities don't come very often. They come far and few when I look back on all the videos I have done. So it's an incredible work that I have uploaded so many topics in the playlist. I hope that you may marvel at the opportunities that come your way. Please don't miss out this video as you will be finding an easy tip to solve the problems related to non-exact differential equations. And let's get going to learn the formulas first. So here is the topic, that is non-exact differential equations. There are usually five methods for solving this non-exact differential equations, and the first method is the inspection method and the rest are using integrating factors. So while using inspection method, we need so many formula here. So here the list of the formulas I have done here, so they will be very useful to crack the solution. The first formula here is the derivative of xy. So here is the derivative of xy. So this is of the form uv, the derivative of uv. So as you know that, so we'll make a derivative for u and we'll leave v, and again we will make a derivative for v and we'll leave u. So that's what I'm doing here. So here I'm leaving x here and making a derivative for y, and later I'm leaving y and making a derivative for x. Clear? And the second question here, the second formula here is also very familiar, that is derivative of x by y. So as it is an x by y, this is of the form u by v rule. So this is u by v, as everybody knows that this will be, so here in the formula it is v square, so here it is y square. So we have to write y for one time and we have to make a derivative for the numerator, that is dx. For x it is dx, minus we have to leave this x and make a derivative for the denominator. As it is so simple, the derivative of xy is nothing but, see here, this is 1 by y square y dx minus x dy. So remember, whenever it is x in the numerator, we have to go with y. So y dx minus x dy. So here, very important, in the numerator if it is x, so here in the answer it will be of an opposite variable, that is y dx minus x dy. And the next one everybody knows here. So this value is derivative of y by x. If it is y by x, clearly it is, so we have to make a square here and we have to write it for one time. So if it is y, we have to go with an opposite variable, that is x dy minus here y dy, y dx, x dy minus y dx. So here I'll tell you a small thing here. In other countries, they'll be telling the numerator as high and the denominator as low. See here. So here I am writing this one as, see, if it is low, so low d high minus high d low by low low. So here it is low low for two times. Therefore, so the formula here will be low d high. So this is low. So what is low here? Denominator. Low d high minus high d low by, this is low low. So in that way also you can remember. And the next one here is the fourth one. The fourth one here is the derivative of log of this value is x by y. So whenever you find a fraction here and it is a log, so please go with 1 by xy. So go with the product. And if it is x in the numerator, go with y dx minus x dy. So this is the easy way you have to remember. And the next one, fifth problem, is derivative of log of, see, y by x. So if it is y by x, if it is a fraction and if it is a logarithm, so whenever you find log, so we have to go with the product in the denominator. So if it is y in the numerator, we have to start with x dy minus y dx. Clear? So this is the easy way to remember. And the sixth question here is derivative of tan inverse of x by y. So if it is tan inverse and if there is a fraction here, please remember in the denominator it will be x square plus y square. If it is x in the numerator, start with y. So y dx minus x dy. Clear? And the next one here is derivative of tan inverse of, this is y by x. So it is y by x. So whenever there is a fraction, remember, and tan inverse, so in the denominator it will be definitely x square plus y square. If it is y, start with x. x dy minus this is y dx. Clear? And the next value here is derivative of log of xy. So if it is derivative, if there is no fraction and if there is log, see, remember, log x value is 1 by x. So in x there is xy. So here x, so you have to leave x here, make a derivative for y, and the next one plus we have to leave y and make a derivative for x. And this is the easy way to remember. And see here, the ninth question here is the derivative of log of this value is x square plus y square. See, remember, there is no fraction here. So there is logarithm. So log x is usually 1 by x. That is 1 by x square plus y square. For x square, the derivative is 2x dx. And for y square, the derivative is 2y into dy. And here, the 10th formula here is the derivative of, so the derivative of e power x by y. It's so important. So here the mostly used formula here. So for y we have to make a square and we have to leave y for one time. For the numerator I am making derivative, that is e power x into dx, minus I am leaving the numerator and making the derivative for the denominator as dy. So as this is so important here, please remember this value is very important. See, the first one is derivative of xy is nothing but x dy minus y dx. So next one is derivative of x by y is nothing but 1 by y square into y dx minus x dy. And the next one, or else it is as if you feel the numerator is high and the denominator is low. So remember this one. This is low d high minus high d low by low. And the next one here is the derivative of y by x. So here it will be x square. And we have to write x for one time, or else if in the numerator if it is y, go with an opposite variable x. Start x dy minus y dx. And the next one is derivative of log x by y, as there is a fraction here. So always there will be the product here. So 1 by xy into. If it is with x, go with y dx minus x dy. So here the fifth one is derivative of log y by x is nothing but, see, xy by x dy minus y dx. So derivative of tan inverse of x by y is nothing but, so as there is a fraction and tan inverse, so in the denominator it will be x square plus y square, y dx minus x dy. So the derivative of tan inverse of y by x, so 1 by x square plus y square. So if it is y, go with x dy minus y dx. So the derivative of log of xy. So this is 1 by xy and make a derivative for xy. So x dy plus y dx. And next one, derivative of log of x square plus y square. So 1 by x square plus y square. This x square 2x dx for y square. This is 2y dy. And the derivative of e power x by y is nothing but, this is y square. Y into e power x dx minus e power x into dy. So these are the formulas which are very important. So while using an inspection method, so I'm going to pick every formula, related formula, and I'm going to transform this in terms of derivative and making integration on both sides. I'm going to cancel this derivative and getting a solution. And this is my plan and this is the process for solving. And see, these 10 formula are very important. Please go through this video before going into the inspection method, and my playlist is in an order. So each and every topic is related to one after the other video. So go through my videos from the first. If you don't connect for one time, please watch the another time, so that it will be very helpful. And really these formulas are very useful for all your friends, and please pass it on to as many friends as you can, and that is the greatest help needed to this channel. And please subscribe to this channel. Stay connected.